Hello, everyone. Let's talk about some technical mathematics that might be of use in many different areas of mathematical endeavor, whether it be physics, engineering, electronics, electrical phenomenon, mechanical phenomenon. Many things can be talked about. The mathematics is practically endless for our purposes. We're not going to know all of it, but we're going to know basic things that we need to know. That's going to help us out. So there are some videos we're going to make pertaining to this and some videos that have already been made, and they'll be available to you, and we'll talk however much we need to talk. Regarding Tech Math 1, Chapters 1 and 2 review, for people that are in that particular class, this is required content. You need to know it, and you need to be able to reflect upon what is being said here and go through the actual mathematical text or review exam and know how to do it. And I'm actually going to walk through that with you, so we should be okay. So we start out here with Tech Math 1. And we're going to talk about chapters 1 and 2, and people associated with this particular class that I'm teaching. This particular class used to have a textbook, and now it doesn't, regarding a technical mathematics class being taught at a technical college. For those of you at the university level that are my students, this is just good review for you, okay? So let's, so just be aware of that. So I mean, for us right now, you're going to have all the documentation that you need, regardless of what your circumstances are. Whether you're at the technical college level, actually taking a class called Tech Math 1, and all the information you need is going to be there for you, or if you're taking some other class at a college or other college or university where this is not formally a class, you still will have what you need here. So, I mean, we know what we're doing. Let's talk about it. Tech Math 1, Chapters 1 and 2 review. Let me run through that, and we'll take it from there. You see that those of you who are in the actual class at the technical college level that I'm teaching will have this documentation as part of a packet that's given to you. Those who are at the university level and are looking at this, you'll have this documentation scrolling for you at the end of this video and at the end of this film, and when I make other films pertaining to similar content, those associated Tech Math 1 review items will also be present for everyone, scrolling at the end of the video. So numerous ways to find all this. So we have all this, you guys. They tell us a few things. They gave us a set of numbers, and they want us to list the whole numbers, the rational numbers, the irrational numbers. So they gave us the real numbers: -5, 2/3, square root of 3, 2.7, square root of 49, and last time I checked, that was just 7. And you got this right here. Number 30. We know what the real numbers, you guys. With the real numbers, there's two major categories. There's the irrational numbers and the rational numbers. Language is a big thing. Rational numbers have associated with them, or the word rational for rational numbers have associated with that particular word, the word ratio. Rational has ratio in it. A ratio of two integers, if you have a ratio of two integers to kind of express a number, or to actually express a number, if you have a ratio of two integers, that's called a rational number. Well, I guess we have to kind of put the carriage in front of the horse on this one. There is a group of rational numbers, also real numbers, are a whole piece of a number, such as, from the negative to the positive, I guess you could say, goes on, the infinite, it's a group that's infinitely big. You got numbers like -5, -4, -3, -2, -1, 0, 1, 2, 3, ... going on forever this way, ... going on forever that way. It is a whole piece of a number, either 0 or some positive number that doesn't have a decimal associated with it, per se, and doesn't have any kind of fractional part to it. It is a whole piece of a number. It could be 0, it could be 0, 1, 2, 3, on, or -1, -2, -3, -4, -5. Those are called integers. If you could write any number as a ratio of two integers, it's called a rational number. There are an infinite number of rational numbers on the number line. All of these numbers that I'm talking about are under the big broad category of the real numbers. The real numbers have two particular categories underneath them, and both categories are part of the real numbers. So the rational numbers get further broken down into these things called integers. Well, I just told you what an integer was. You get integers. Underneath the integers, you get something called the whole numbers. The whole numbers are the numbers on the right-hand side of the integers. 0, 1, 2, 3. Every integer that's not a negative number is called a whole number. Underneath the whole numbers, you get these things called natural numbers. And those are even more confined. You don't even put 0 on that one. The natural numbers are sometimes called the counting numbers. Start to count from 1 to 10. Well, I don't start at 0. I could. But the way they usually talk about the counting numbers, they say 1, 2, 3, 4, etc. So these all are under the rational numbers. The irrational numbers are most of the square roots, not all of them, but many of the square roots, many of the cube roots, the number e, the number pi, so on and so forth. They are numbers that have a decimal expansion that goes on and on forever and does not repeat. You cannot write them as a rational number. The name betrays that reality as well. The irrational numbers are numbers that are not a ratio. They are not a ratio of two integers. So integers play a big role as what's going on right here, guys. Okay, with that having been said, let's run through this. And again, there's other videos I have on this where there's more detail on this, and we also talk about laws of exponents and some other things and how to do multiplication of fractions, division of fractions, addition of fractions, subtraction of fractions. That I have in another video, so you can look at that as well. I'll probably put that up in front before we even look at this video. So we'll put them in some kind of an order. All right, with that having been said, let's see if we can draw some conclusions. And like I said, in an earlier video that'll be available to everyone, you can look at the rules of multiplying fractions, dividing fractions, adding fractions, subtracting fractions, the laws of exponents, things like that. That'll all be elsewhere to be found, and it'll be more or less prerequisite to starting even something associated with this particular film on chapters 1 and 2 for the review. They want you to list the whole numbers. The whole numbers are 0 and bigger, but they're a whole piece of a number. The square root of 49, yeah, it's 7. You got 30, and that's it. That's it. Those are the whole numbers. The integers is another dynamic. It's -5, the square root of 49, which is 7, and 30 right here. Just see how they actually, they write it like that. So this is the set of this, and that's really just 7, 30. That works too. Those are the whole numbers. The rational numbers are things that can be written as a ratio of two integers. Well, -5 can be written as -5 divided by 1, -5 divided by 1, or -10 divided by 2. That'll get you -5. It's a ratio of two integers. So that certainly works also. -5 is a rational number. 2 is an integer, 3 is an integer. It's a ratio of two integers. You got that. 2.7 also works. Why? If you took 27 and you divided it by 10, you get 2.7. So that works. That's rational. Square root of 49, I mean, it's a little awkward at 7, and 7 is the same as 14 divided by 2, so that works. And 30 is the same as 30 divided by 1, or 60 divided by 2, so all these work. So these would be, for number 2 here, so here are the whole, for this numbers, here are the rational numbers. And 3 lists the irrational numbers. Well, most of the square roots are going to do that. Now, square root of 49 is 7. That's certainly not going to do it. The only thing that's going on forever and not repeating is the square root of 3. I mean, there's approximations to it to any degree you want, but it still goes on forever. Again, we go into this stuff in different places, guys, so I'm not, it's more a topic that I think you're going to find, you can talk more about this in other work that we've done. So it's earlier videos that I'm going to expose you to, and in person when we can talk more about some of the stuff that's associated with this, you guys. They go into 4, 5, and 6, and they write down this, and they say that's equal to this. So they're kind of doing a little bit, they're doing a few things here, so you got to be careful with what they're doing. Two, you got that, and you got this. Well, basically, you guys, there's these pretty broad categories, I guess you can talk about, and so let's talk about them a little bit, if you don't mind. You talk about the associative type properties. Associative property for either addition or multiplication. And the way that plays out is, if I got A plus B plus C, and I associate them like that, that's the same as writing A plus B plus C and not changing the order, but associating them in a different manner. That's associative property of addition. If it was a multiplication going on, you can write them both in order like that. You can associate like this, or you can associate like that, and they're still equal. So those are the associative properties. The commutative, and like I said, elsewhere I think I have coverage of this in other films, but sometimes we can look at this as well and be okay. Commutative property of addition and multiplication. This is for addition with the associative and multiplication with the associative. For the commutative, you could have A plus B, and that's the same as B plus A. Here you're actually picking them up and moving them. You're commuting them. That's commutative property of addition. If you have this, you can switch the order. That's commutative property of multiplication. There is this thing called the distributive property. And it kind of speaks for itself in a sense, I guess you could say. Let's say you had A times the quantity B plus C plus D or something. You put a whole bunch of things in there if you want, as many as you want actually. Well, if I got that, if you are multiplying, if you're first adding these together and then multiplying with A, you get an answer. But it's the same as taking A and going inside and multiplying each one of them and then adding. You can distribute. You can distribute the A in this case and get it. There is the identity property. And that's interesting as well. I mean, if I take 0 and add it on to A, in any order I want, in fact, A is A, and 1 times A is A. This is the identity property for addition. This is the identity property for multiplication. So that's kind of where they're going with this. Well, right here, you got 5 plus negative 9, and now you got negative 9 plus 5. That's the commutative property. So that's based on what we just said. Commutative property, and I'm pretty sure I wrote this wrong. Yeah, or at least spelled it wrong. Okay, let me see here. Commutative. All right, there you go. Commutative property. The other issue here, yeah, everybody's in the right order. You're just grouping them differently. That's the associative property. Here, this is the identity. You add 0 to anything, you get the original anything you had to begin with. There you go. So that is that. Let's keep going. So we're looking at something of that nature. Like I said, guys, there's another video that has this and some of the more basic stuff before you initially even try to look at some of the technical mathematics that we're talking about here, or at least basic technical mathematics. That's up to you. Many people already have the background. If you don't, there's, like I said, I have earlier videos where I go into in some detail regarding some of the laws that are of great use to us when we're doing this. And some of them are going to get hit here as well in the discussion that I'm doing here with the first film pertaining to some of the technical mathematics, chapters 1 and 2 that I'm doing right now. But there's earlier stuff that you can look at as well, and we'll be looking at, of course. Okay, so what I have here, I'm always checking the screen here, guys, make sure I've got everything's functioning well with the filming of this content. Okay, let's keep going. Looking pretty good. Add or subtract, report fraction answers in lowest terms. Oftentimes when we're dealing with fractions or non-fractional type numbers or mixed numbers, usually the safest way to do it is make all the non-fractional numbers and make all the mixed numbers that have a regular, quote-unquote, regular number, whole number type thing, or integer in front and then a fraction with it. Take the non-fractional numbers and the mixed numbers and make them into fractions, make everything into fractions. And when you're adding or subtracting fractions, you have to have a common denominator. When you add or subtract fractions, you have to have a common denominator. When you multiply or divide fractions, you don't need one. All right, so more to come on this. So if we look at something, there's a bit of a tug of war that takes place. There's some pretty fascinating rules that happen. I've got other coverage of this in other places, but let's kind of decide how we want to do some things. There is, guys, and I do definitely have this elsewhere for you to look at, but what the heck, for the sake of being somewhat rigorous, I guess you could say, let me talk about real numbers and some kind of interesting things that's associated with them, I guess you could say. If you want to talk about multiplication of any two real numbers, or division of any two real numbers, or addition of any two real numbers, or subtraction of any two real numbers. Let's get there. Let's talk about it. And like I said, we have this in other places as well when we say this stuff. If you ever multiply any two real numbers whether they're decimals, whether they're mixed numbers, whether they're fractions, whether they're irrational going on forever, whether they're positive or negative, it doesn't matter. If you multiply 0 with any real number, you get 0 for an answer. If 0's in any kind of multiplicative array and you're doing multiplication, 0 multiplied with any array of real numbers is going to give a final answer of 0. Okay, we know that. If you multiply anything, so we've got that. You're not allowed to divide by 0, but 0 divided by any non-zero number is also 0. Okay, got that out of the way. If you multiply any two positive real numbers, you get a positive real number. If you multiply any two negative real numbers, you still get a positive real number. If you multiply any two real numbers that are of opposite sign, you are going to get a negative real number. And there's some neat mathematics that discusses this and makes it valid when people are doing algebra. And this stuff really works. It's not just something they arbitrarily design. When they're looking to solve problems that, can be pretty difficult, but they're pretty important to be solved. They're very important to be solved correctly. The mathematics is true. It works. And engineers and others, they bet everything. I mean, on it being right, and so as long as the mathematics is on. If you divide two real numbers that are both positive, you get a positive answer. If you divide two negative real numbers, you get a positive answer again. If you divide two real numbers that are of opposite sign, negative on the top, positive on the bottom, positive on top, negative on the bottom. I don't know how well that's visible, guys. It's hard for me to know how all this stuff films out sometimes. Let me try to give you a little more room. If the signs are mixed, you get a negative answer. Wait a minute, this is kind of interesting. There's a lot more to be said, guys, as with so much of mathematics, and there's so little time to say it sometimes. So at least we have to know at least the basics and be able to function with it. And hopefully down the road we look at it, we can look at it more rigorously whenever we have the time to do so. Okay? Let's talk. Whenever you multiply any two real numbers that have the same sign, so I want to make that very clear. That's a negative for some reason. There's a mark on the board here. Hopefully you don't see it to confuse you, but make sure those two are negative. Okay. Whenever you multiply any two real numbers, and they're both positive or both negative, you get a positive answer. If you multiply any two real numbers that are of opposite sign, you get a negative answer. Say that again. If you multiply two numbers that have the same sign, you get a positive answer. If you multiply two numbers that have opposite signs, you get a negative answer for real numbers. Multiply any two real numbers with the same sign, you get a positive answer. Multiply any two real numbers with opposite signs, you get a negative answer. Same thing happens with division. If you divide two real numbers that have the same sign, you get a positive answer. If you divide two real numbers with opposite signs, you get a negative answer. Both instances. If you multiply or divide two numbers that have the same sign, you get positive answer as a result. If you multiply or divide two numbers opposite signs, you get negative answer as a result. If you add two positive numbers, you will get a more positive answer. If you add two negative numbers, you get an even more negative answer. Okay, makes sense. Try to get this out of here so it doesn't look like a positive. So that's a negative answer. If the signs are opposites, of opposite sign, well, there's a lot that can happen. Either a negative plus a positive or a positive plus a negative. That's not a big deal. The big deal is how this whole thing ends. You can get, if they are of the same magnitude but of opposite sign, if their absolute values are the same but they're of opposite sign, if you add two things that are of opposite sign but the same magnitude, you get 0 as an answer. If the positive number has a bigger magnitude, it wins the tug of war. You get a positive answer. If the negative number has a bigger magnitude, bigger absolute value, then you get a negative answer at the end. It's a tug of war. The best way to If A and B are two real numbers, A minus B is A plus the opposite of B. If you're ever really in doubt when it comes to subtraction, convert everything in the array into addition. It makes it a lot easier. It's a lot less confusing. More to come on that, however much people want to talk about it. Number 7, they're saying, let's add these up. They're saying negative 9 plus 13 plus negative 3. Well, I'll tell you what I'm going to do. I'm going to take two negatives and put them together. If I add two negative numbers, the result's even more negative. I lost $9 when I went to that casino. Then I played again, and I lost another 3. That's certainly not a positive answer. People say positive and positive is negative. No, it isn't. Positive divided, negative divided by negative is positive. Negative times negative is positive. I agree that. That's not the same as saying negative plus negative is going to be positive. No, negative times negative is positive, and negative divided by negative is positive. But not this. Negative 3, a loss of 3 and a loss of 9 is a loss of 12. Loss of 12 and 3 is 1. That's what you want. That's what you want. They're asking 3/10 minus this. Well, minus a minus is interesting. Minus a minus is plus. Let's see how it plays out. And again, there's more to come. I don't want to do everything over from stuff I've done earlier. You'll see the earlier videos, and hopefully that'll help you. Minus a minus is plus, or it's the same as minus this is plus the opposite of this. Well, the opposite of the opposite is just positive. It's going to be 3/10 plus 5 over 6. Tell you what I'm going to do. I can go 6 times 10. Whenever you're adding or subtracting fractions, you have to have a common denominator. You have to have a common denominator. Well, I'll tell you what I'm going to do. I can go 10 times 6 and get 60. I got maybe a smaller number. How about 30? Does 10 go into 30? Yeah, 3 times. Does 6 go into 30? I'm going to have a common denominator of 30 for both of these and figure out where it's going to go. What do I mean? Well, I mean 3 over 10 is going to be something over 30. I mean 5 over 6 is going to be something over 30. By what would you multiply 10 to get 30? You got it. By what would you multiply 6 to get 30? You got it. 3 times, you'll get the common denominator here, using a special 1 to kind of speak the language. 3 times 3, 9. 3 times 10, 30. 5 times 5, 25. 5 times 6, 30. Yeah, 5 over 6 is mathematically equivalent to this. You don't believe me? Why don't you reduce this? Doesn't 5 go into here 5 times? 5 goes into here 6 times. You got 5 over 6. That's what I got here. Reduce this. 3 goes into here 3 times. 3 goes into here 10 times. 3 over 10. It's this guy right here. So you're never changing what it is. You're making it something that's more palatable in a sense. This is 9/30. This is 25/30. Once you need to have a common denominator to add or subtract fractions. Once you have that common denominator, you absolutely leave it alone, always, and add the numerators. The numerator's on top, the denominators are on the bottom. You have a common denominator, leave it alone forever. Add the tops. You got 34. Well, yeah, usually they want things reduced to lowest terms, you guys. So let's see how we can look at that a little bit. So this can be broken down. 2 goes into here 17 times. 2 goes into here 15 times. Okay, that'll work. That is an improper fraction, but it's a fraction. Usually, depending on what the teacher mandates how they want something reported, this itself is mathematically valid, and it is reduced to lowest terms. 15 does go into 17. You can write it as a mixed number. 15 goes into 17 one whole time with 2 left over. You can write it like this. These are both equal to each other. They're both equal. Mathematically, all 3 of these are equal. This is just reduced to lowest terms, but it is an improper fraction. You can leave it alone, or you can write it like this. See how they're actually reporting some of these. They left it like this, and this would be as a mixed number. to write that. So it's looking pretty good that way. Multiply or divide, report fraction in lowest possible terms, lowest terms. So we were doing that earlier. So we got you guys. Remember this here, and let's take some of this stuff out. Like I said, these videos can be used in a myriad of circumstances. If you know how to do this stuff, then you don't have to worry about it. I guess you don't have to look at these, but I think that's always good practice. If you don't know what's going on, then it is kind of required to look at it. You got to know this stuff. If you're going to do any serious look at any kind of engineering, any kind of electrical technician stuff, electricity, mechanical type things involving mathematics, any kind of serious look at mathematics, you got to get the foundations. You should be doing this stuff. Let's talk a little bit. Let's see how it goes. I want to make sure this stuff is visible. So I think I'm okay. All right, guys. I mean, whenever you add or subtract fractions, you must have a common denominator, and you will then find that common denominator because you need a common denominator whenever you add or subtract fractions. But once you have done that, you leave it alone and just work with it. So when you add fractions, you have to have a common denominator. When you multiply or divide fractions, you don't need a common denominator. Whenever in doubt, convert everything into fractions. It's probably an easier way to do it. Let's take a look. They're saying, again, this will scroll in the video, and those actually at the technical college with me that are doing this, you'll actually have a hard copy of this and the scroll that's going on. Those looking at this in some other context at the university or elsewhere, you still have the actual document scrolling at the end, so without having the hard copy. So you're okay if you wish to have that. So we can use this in multiple contexts at different schools, as we've already said. All right, so you're looking at something like this. Negative 2/3, and here's 9/10. Let's go for it. There's a lot of ways to go. Tell you what, the formal rule of doing multiplication. Again, when you're adding or subtracting fractions, you must have a common denominator. We've gone there. When you're multiplying or dividing fractions, you don't need a common denominator. The most basic way to do it, if you get in trouble, is just multiply the tops across, get a new answer on the top, and multiply the bottoms across and get a new answer on the bottom. You multiply the numerators across, you multiply the denominators across, and then maybe look to make a cancellation. Multiply the numerators across, follow the rules that we've shown, multiply this way, you got this. I'm looking at this, I don't know, I'm thinking -3 times a +6, not a bad guess. I'm thinking 5 times a +6. And there's your answer. It's the end of the story. And it is reduced to lowest terms. You also could have said, you know what, I'll do this thing called cross cancellation. That's not cross multiplication. That's something different. I'll do cross cancellation. 3 goes into 9 3 times. 2 goes into -2, -1 time. 2 goes into here 5 times. 1 times 5 is 5. -1 times 3 is -3. That looks awfully familiar. So that'll work either way, you guys. For number 10, here's the question, and we'll kind of play some games with it, I guess you could say. You got this right here, -8/7 divided by -2. Whenever in doubt, if there's fractions present, very, very oftentimes, it's a good idea to make everybody into fractions. It kind of makes it easy. Now, when you divide two fractions, you take the first fraction, the one that's being divided, in this case, the one on top. When you take, it's the same thing as this right here. It's written like this. It's written as -8/7 divided by -2. These mean the same thing. The first fraction is divided by the second fraction. Top fractions divided by the bottom fraction. They mean the same thing, the two things I just wrote. Now, when you're looking at this, the way you divide fractions is basically like this. This -2 to me looks a lot like -2 divided by 1. Whenever in doubt, make everybody into fractions. The rule is A fraction divided by another fraction is the first fraction, the one that's being divided, left alone, multiplied by the reciprocal of the second fraction doing the dividing. Every division problem can be turned into a multiplication problem if you're careful. A fraction divided by another fraction is that that's being divided left alone. Flip the one doing the dividing and the whole thing into a multiplication, and you're there. You look at this, negative, just do the multiplications. I've already told you how to do it. 7 times negative 2. Let me think here. I will think. Negative 2 times 4 is negative 8. And negative 2 times 7 is negative 14. That's pretty interesting. They cancel. And I guess it's consistent with the speech I delivered earlier in the video. Divide a negative by a negative, you get a positive answer. You could have gone over here. You could have said, wait a minute, what is he doing? A negative 2 goes into negative 8, positive 4 times. 4 times 1 is 4, 7 times 1 is 7, 4 over 7. Yeah, absolutely works. A fraction divided by another fraction is the first fraction multiplied by the reciprocal of the second fraction doing the dividing. Well, we already did that song and dance. We got over here and we did it. Okay? So that's how it all plays out, you guys. Again, there's a lot of stuff that gets talked about in different contexts, and we'll try to be pretty straightforward with what we're talking about. When you're talking about laws, and again, there's laws of exponents I'm going to have elsewhere, and you'll see it earlier than before this video. But, you know, there's nothing wrong with seeing something again. To a large extent, I don't want to get into all the what ifs, but if you got some x and you take it to the 0 power, it's equal to 1. X to the 1 is equal to x. X to the m times x to the n, if there's a common base, the x on the bottom is the same for both, you add the exponents and put it on top of the x. If you're dividing two exponentiated quantities, you're subtracting exponents. If you're exponentiating an exponentiated quantity, that's when you multiply the exponents. If you've got a ratio of two real numbers and you're taking it to the nth power, it's the same as doing the ratio of the exponentiation. If you're exponentiating a ratio, it's the same as the ratio of the exponentiations. If you're exponentiating a product, it's the same as the product of the exponentiations. The exponentiation of a ratio is the ratio of exponents. The exponentiation of a product is the product of exponents. Later on, they pull very similar stuff with us when they talk about taking the root of something. Like I'm going to take the root, the nth root, the square root, the third root, whatever root that is, the nth root. The nth root of a ratio is the ratio of the nth roots. And I discussed that elsewhere, so I'm not going to start it from scratch again, guys, but we will see it, and we'll see it in person, those that are taking the class pertaining directly to this, and we'll see it in other videos. So the root of a ratio is the ratio of the roots. The root of a product is the product of the roots. So that's pretty interesting. And there's some other things that happen. Maybe I'll touch on it now. Again, we can see it in other places as well. And then we'll look at this. I mean, we've already seen it. We'll have seen it a number of times. But I think it's good for us to look at this stuff. So that's pretty interesting stuff. I mean, and there's a lot to talk about. Let's kind of plays its own kind of role, I guess you could say, in a lot of stuff. So since we got this far, forgive the tangent I'm taking, guys, and we do see it elsewhere, but I think it's maybe good for us to look at and then kind of work with what we're going to say. I can tell you that if you take, kind of let's tie the exponents. There's a close connection between exponents and roots. They're kind of two different sides of the same coin, if you allow me to say. If we're talking about the roots, and if we're talking about exponents, I can write every exponent. Arguably, I could probably write it as a root. Though I can for sure. I don't want to get too adventurous in this. I can write every root as an exponent. That's for sure. And so pretty interesting how that plays out. How does that play out? If you had n is, there's a lot of what ifs in this, guys. There's a lot of scenarios here of interest. Let me say one more thing. It's pretty important to kind of look at. If you got x to the negative n, where n is a positive number, x to the negative n, it's 1 over x to the positive n. It's the whole, that whole thing. So let me, erasing this stuff doesn't look too good sometimes, but there it is. You put it underneath like that. So that's some of the language they use. There's a reason for it, and it's mathematically valid. For our purposes, I'm going to say something different. I'm going to say x to the 1 over n, where n is a positive number again. That is not the same as 1 over x to the n. Is that clear? 1 over, here it's x to the n, whatever the answer is, and then you're putting it underneath 1. This is x to the 1 over n power. Two different things. X to the 1 over n, where n is a natural number, is the nth root of x. By definition. So, if I were to take x to the 1 over n and take the whole thing and take it to the m power, it's the same as taking the nth root of x and putting that to the m power. Yeah, but what did I say here? If you exponentiate, if you exponentiate an exponentiated quantity, you multiply the exponents. Well, if you multiply these two natural numbers for our purposes, m times 1 over n, well, m times 1 over n is the same as m over 1 times 1 over n is the same as m over n. Well, that's pretty interesting. So basically, x to the m over n can be written as the nth root of x, as I was doing here, taken to the m. Time out. I mean, that's true. Let's draw kind of a broad conclusion to this then. If I'm going to play the game of mathematics with this, let's play it two different ways and get the same answer, but get the same answer expressed in a different manner. X to the m over n and x to the m over n, what do we got? You could write it, my friends, as the m right here and the 1 over n on the outside. Is it true that 1 over n times m is the same as, you can play the whole game. Of course, I ended up erasing it. But if I said, either way I play this, m times 1 over n, that's m over 1. Multiply across on the top, multiply the cross on the bottom is like that. If you got the 1 over n over here and the m over 1, by the commutative property, notice how all the mathematics ties together. 1 times m is m, n times 1. So, okay. I'm looking at that. But what did I say to the 1 over n power means? To the 1 over n power means the nth root. So this guy can play like this. Is there another way to look at it? Yeah, I think there is. What if you put the 1 over n on the inside and the m on the outside? What about it? Well, that's kind of neat. X to the 1 over n is the nth root of x, and m is on the outside. These are two different ways of expressing the same thing. Pretty neat stuff in that regard. I mean, you got this guy right here, and you got this guy right here. And they both pertain to this. So that's a pretty fascinating conclusion. And it might have some, there's potential strength in that depending upon what kind of problems we're trying to solve. But definitely some pretty fascinating stuff. Okay, I wanted to digress a little bit and go there, and I just did. You'll see this in other contexts, in other films I've done, but I thought this was something pretty important to kind of look at. Okay. With this in mind, and again, you have the feature. The good thing about a film is you can always go back. I sometimes forget that people can do that, so I go a little bit slower and I keep stuff up there for a long time. But some stuff is good to have up there, I guess. A lot of ways to express what you want to express, I guess you could say. So let's see what we have. I mean, all right, guys, so there's a number of things that go on. Let me leave some stuff for a little bit, I guess. All right, well, they talk about a few things here, guys, and I give laws of exponents, and I think we should be pretty okay to get the answers that we're going to get. I just want to make sure I'm speaking the language that they're speaking here. There's a number of ways to write the right answer, guys, sometimes. I'm just trying to be consistent a little bit with what the answer key is saying. But yeah, be aware. There's potentially a number of ways to write the same right answer. So as we look at this, we got 3 to the 4th times 3 to the negative 2 times 3. That's not 3 to the 0. 3 to the 0 is 1. 3 to the 1 is 3. So I'm going to put that on there right off the bat. I'm just adding these. I'm adding the exponents. 4 plus negative 2. Can't call it 0, though. 3 to the 0 is 1. 3 is not 1. It's 3. So 3 to the 0 would give me 1. 3 to the 1 will give me the 3 that I had. Be careful. 4 plus negative 2 is 2, and 1 is 3. 3 to the 3. Now, is there another way to write this? Yeah, 3 times 3 times 3 is 27. It's not 9. It's not 3 times 3. Be careful. 3 to the 3rd is 3 times 3 times 3. Multiplication, you guys, if I said to you, 5 times x, that's not the same as x to the 5th. 5 times x, multiplication is repeated addition. There's handouts for that as well, guys, that I'm going to get to you guys. But this is 1, 2, 3, 4, 5. So 5x, there are other ways to write this too, but for our purposes, other ways to write it, of course. 5 times x is repeatedly adding x in an array 5 times. So 5 times x written down 5 times in an additive fashion. X to the 5th is x written down 5 times once again, but in a multiplicative fashion. So multiplication is repeated addition. Multiplication is repeated addition. Exponentiation is repeated multiplication. Okay? That's number 11. Let's see how they want to talk about some of the stuff that goes on here. So we look at 12. 6 to the 0 taken to the negative 3. Well, you multiply the exponents. 0 times negative 3 is 0. 6 to the 0 is 1. Be very careful. And the reason for that is 6 to the 0 inside here is 1. To the negative 3 means 1 over 1 to the positive 3. 1 times 1 times 1 is just 1. 1 over 1 is 1. I mean, the recipe gets you the answer pretty quickly. If you look at it rigorously, which you don't always have time to do, you're still going to get 1, of course. Okay? So that's 11 and 12, you guys. 13. 7 to the negative 2 and 7 to the negative 3. How does that work? You subtract. Minus a negative 3 minus a negative 3 is plus 3. This and this is 1. You got it. You got it. A little more rigorously. 7 to the negative 2 is 1 over 7 to the positive 2. 7 to the negative 3 is 1 over 7 to the positive 3. A fraction divided by another fraction is the first fraction left alone multiplied by the reciprocal of the second fraction doing the dividing. That's 7 to the 3 over 7 to the 2. 7 to the 3 is 3 of these 7s in a multiplicative array. It's not 3 times 7. It's 7 times 7 times 7. It's a big difference. 3 times 7 is 21. 7 times 7 times 7 is 343. That ain't 21. Just watch out. Know the math. 7 squared is 7 times 7. These cancel. These cancel. You got 7 left over. I already said you had 7 left over, but it's nice to look at. It's nice to be able to know how that plays out. Whenever we have a chance to look at things more rigorously, we'll try to do so. Okay? Again, the game gets played the same way, you guys, and you can take it to the degree of rigorousness that you would like to take it. It's your call. 2 to the negative 3, got 4 right here. 4 times negative 3 is negative 12. They want you to write as, and I don't, there's different ways this gets written. Let me just make sure, I'm going to just try to speak the language of the people speaking it. This is fine. Usually they like answers. This is fine. But usually they like answers written as positive exponents. So 2 to the negative 12 is 1 over 2 to the positive 12. Okay? I want to make something clear one more time. I mean, if I say 1 over 2 to the positive 12, that's what that means. That is not the same as, that's not the same as 2 to the 1/12. It's a different story. This is the 12th root of 2. Find me the number such that if I took it to the 12th power, I would get back to 2. I'm getting the 12th root of 2. Yeah, they're not equal. I've already gone into that. I mean, we've already said that. But it just to give you that idea. Okay, so be aware. This is okay. okay also. Okay, number 15, convert to standard decimal notation. Typically, guys, when you're talking about exponential notation, scientific notation, you go for a number between 1 and 10, not including. And again, I talked about this elsewhere, not including 10. Okay? Between 1 and 10 is the lead number times, 10 to the 1, 10 to the negative 1, 10 to the negative 2, 10 to the negative 10, 10 to the 10, 10 to the 100 if it's a huge number, 10 to the 5, et cetera, et cetera. You go for the lead number, guys, being that way. So what we got here is, let me just see what I got. So the lead number goes between here, and then the tail number is going to, go here. That's scientific notation. I can express any number I want, any real number I want, in scientific notation to any degree of accuracy that we want to do that. Okay? So let's see what we can do. Figure out how we're going to do some of this stuff, guys. So let me, as you can see, I'm pretty fond of this, so I'm leaving it up here still. You guys can always go back on this stuff if anything does get erased, right? And I think right about now I'm going to erase just about everything and kind of go for it. So let's start talking about the scientific notation and things of that nature. So, all right, let's cover some ground on this. Let's figure out what we're doing. Convert to standard decimal notation. Interesting game the way it gets played. If you got 3.61 times 10 to the negative 3, kind of pretend your piece of chalk or your pen or your pencil is where the decimal point is. Negative, walk over to the left. Take a walk. Using the 3 as well as part of the walk. You start right here, so you walk over 1, 2, 3. Tack on zeros if there's nowhere to go. You get that. Okay? Convert to scientific notation. So for 16, you're going the other direction here. Well, let me look at this thing. I mean, it's 0.188. Take a walk. It's got to be between 1 and 10. So I'm going to walk over 1, and I'm going to make it bigger by a factor of 10. Me having made it bigger by a factor of 10, I got to compensate for that by making that bigger by a factor of 10, multiplied with something, making it smaller by a factor of 10. Negative 1, huh? Negative 1, take a walk to the left, and you're right there. You design it 1 and 10, but wait a minute, it's too big. It's 10 times too big. Well, then make that 10 times too big, make it 10 times too small, and it's the original you got. Take a walk 1 over to the left, and you're there. 17, 963, let's do it. Let me get a number between 1 and 10. Sounds good to me, it's right here. Where it is, there it is. Go 1 over, 2 over. Oh, 2 over, huh? If I go 2 over to the right, I get 963. This is what I started with. How do I get it now when I go between 1 and 10? Go 1 over 2 over to the right, to the 10th power, to the second power rather, gets you over there, as you're supposed to go. There are a number of ways to write some things, so let's just keep going and we'll see what we can say. We're talking about this. R sub t is R1 times R2 They're saying this. They're saying find R sub t if they tell you R1 is 150 and R2 is 100. R1 is 150 and R2 is 100. They're giving us that. Okay, that should be pretty okay. Just be careful. Not difficult, not a difficult move. Just watch what you're doing. There's probably good shortcuts you can take too. R1 is 150. R2 is 100. Underneath, it's R1 plus R2. So it's 150 plus 100. Sounds good to me. Sounds good to me. I mean, there's a lot of ways we could play this. Let's just go. I'm kind of debating with myself how to do this. There's a whole bunch of ways. You can flat out by brute force just multiply this thing right here. 150 times 100 is 15,000. You add these two together, you get 250. 250 goes into 1,000 4 times, and there's 15 of those thousands. The answer is going to be 60 if you just grind it out. There's a number of ways you could have done it, but that should be the answer at the end. I'm going to always be checking here. Make sure that the answer key's right, and of course, probably more check out to make sure that I'm right. So yeah, that's right. That works out. That's 60. See what I got here. They got 19. They're playing kind of a similar game that we played before. So let's keep playing the game, I guess. So 19 is saying when t is equal to 3 halves, they don't make it that easy to look at. Now 3 halves is 1.5. It's good to keep that in mind. Maybe it's easier to deal with 1.5 rather than 3 halves. Maybe it isn't that easy to deal with it, so maybe don't. So we got, see what the heck's going on. Well, I mean, they're doing a couple things here. You got t squared. You got 3 halves squared. We've talked about that phenomenon a bit. Here we got 3 halves, which is 1.5 minus 1. And let's see how it plays out. 3 halves is 3 halves times 3 halves, which is the same. We bring the square in here, bring the square over to here, and bring it over to here. 3 squared is 9, 4 squared, forgive me. Bring the square in here. 3 squared is 9, 2 squared is 4, 9/4. Okay, we'll cross that bridge when we need to. This minus that is just a half. Times 2. Order of operations, you guys, you're never doing addition or subtraction until you're done with all the exponents, until you're done with all the multiplication, until you're done with all the division, unless there's brackets or parentheses. If there's brackets or parentheses present, you do it first. Do everything that's inside the brackets or parentheses. When you're done with that, do exponents and roots. When you're done with that, do multiplication and division. When you're done with that, do addition and subtraction. Now we'll deal with it. Well, let's leave that alone. 2 times a half is 1. You got 9/4. I don't know why my chalk is not writing well, but okay. It's some of the best chalk there is, guys, I think. That's what I'm using. This is 9/4. This is 1. You can play this a bunch of ways. 1 is the same as 4 over 4. 1 is the same as 4 over 4. This is 9 over 4. Do the subtraction, you get 5/4. which is 1 1/4. The 5 is 1 1/4. It's 1.25. This, and this, they're all the same. They're probably using 5/4, and probably it's the end of the day on that one with the way they're doing it. Yeah, 5/4 is fine, but they're all the same. 5/4, 1 1/4, 1.25. Okay. Number 20. Okay, they give kind of an elaborate setup on this one. Let's go for it, I guess. Before I erase a lot of stuff. Here's 20. And they're saying, please evaluate the following. Again, the addition and subtraction, if it's not within brackets or parentheses, is the last thing you're doing. You add and subtract at the very end. Now, if it's within parentheses, that's the first thing you're doing. So that's kind of interesting in its own right. This -1 doesn't mean a whole lot, but the way it's in parentheses just means, hey, heads up, you're going to do a multiplication. You will not do this addition. You'll not do this addition, guys, until you're done with this and this. You're not going to do this either until you're done with this and done with that. Okay? So the way this plays out, let's play that game, I guess. Here's this. This is 20. This is, okay. What is 10 minus 4? Well, 10 minus 4 is 6. Here's the minus. We'll get there. Here's 20. Let's see what we got here. So this is 6. I don't know why the chalk is doing this, but okay. Using the wrong end maybe. Here's 20. Here's the minus. We'll get there. So the 10 minus 4 was 6. 5 times -1 is -5. We're going to add 7. We're going to figure it out. Do not cross the line until you've completed this and completed that. Let's see what we got. 3 times 6 is 18. 3, don't touch this. And don't cross the line until you've taken care of everything on top and everything on the bottom. 3 times 6, 18. -2 plus +7, that's 2. 20 minus 18 is 2. 2 on the bottom. 2 divided by 2, that's an elaborate argument at the end just to get to 1. But that's the answer. That's the answer at the very end. So we got there. Absolutely. Okay, that was problem number 20. We're going to go all the way through 35, guys. I'll try to take a decent pace on this. Because, again, you always have the feature. You can slow this down a little bit and always come back to it. All right. Hopefully this is looking good for everyone. Like I said, those that are in my actual class, we're actually doing this explicitly, not just as augmentation for, let's say, another class. I mean, in different circumstances, this is just background knowledge and augmentation and stuff for maybe a different subject matter, and the math has to be known. For classes where we're actually looking directly at this, in person we'll be doing some of this as well, when the class is specifically geared to the technical mathematics. If it's just an augmentation to the physics class that you're taking, the university level, that's you're not going to be seeing this explicitly except for in this film, you guys. All right. All right. I just want to tell you that in the first film, guys, and from here on in, we'll get through it. So, okay, there's a number of things here. Let's see how it plays out. The thing with algebra is you do the exact same thing on each side of the equation. If you add, you add the exact same thing on each side, you multiply by the exact same thing on each side. So you got to be careful. See what we can do. For 21, we got x minus 2.5 equals 4.1. Yeah, if two things are equal, I mean, the minus 2.5, you can write it as plus a negative 2.5. Or you don't have to. I mean, if you're subtracting 2.5, why don't you add 2.5 on each side to solve it? Minus 2.5 is plus the opposite of 2.5. If you add the same thing on each side, it's still an equation. Your goal is to get the x all by itself. Well, it's going to be all by itself right about now. Negative 2.5 and positive 2.5 is 0. 4.1 and 2.5 is 6.6. So there's the x, you guys. Okay? X equals 6.6 for that one. For 22, we're talking about d plus 1/6 equals 5 over 6. Subtract 1/6 on each side, or add the opposite of 1/6. Adding a negative 1/6 is the same as subtracting a positive 1/6. If I subtract 5 from 10, I get 5. If I add a negative 5 to 10, I still get 5. If I subtract 3 from 10, I get 7. If I add a negative 3, if I add a loss of 3, I still get 7. So I like to add. A lot of times in mathematics, it's good to add. It looks a little awkward sometimes. But if you add the same thing on each side, add a negative 1/6 to a positive 1/6, they cancel. D is here. 5 over 6 plus negative 1 over 6. 5 and negative 1 is 4. You got this. Does that cancel? Yeah, it cancels out. I mean, 2 times 2 is 4. 2 times 3 is 6. It's 2/3. Usually you want things written in lowest terms, guys. That's usually the best way to approach it regarding that. Okay? That's 22. 23. Again, here it's nice to understand why adding's usually a good idea. It's not the only way to do this, and you don't have to do what I'm doing. What you do have to do is get it right. How you get to a particular place in order to help people doesn't matter. Let's say you're a paramedic or an EMT or some sort of worker helping people. Well, if you can, the big thing is get there, right? Now, if you're going to fly there or take the ship or take an airplane, take a ship, take a train, drive a car, take a bicycle if it's close by, whatever, but you got to get there. So I don't care how you solve these problems as long as you do it honorably, fairly, and you get them right. And because there's a lot of ways to think out the whole process. Basically, guys, I think you're really good idea, and you've seen me kind of pull that already. It's good to convert things to addition. You've already seen me do that. Take a look at it. It's looking like this. Tell you what I'm going to do. Minus 12s is plus the opposite of 12s. Yeah, that makes it easier, believe it or not. Let me subtract 7 on each side, or add a negative 7 on each side. 7 and negative 7 is nothing. Notice how now with the pluses are easier to deal with. You're not messing with the monkey business of a subtraction. If you got another way to do it, go ahead and do it. But I think when you convert things to plus, 4 and negative 7 is negative 3. I got to here. It's easier when you convert everything to addition because you can kind of just truncate everything a lot easier. If there's a subtraction symbol there, it's sometimes confusing to know how you're going to get out of this. And there's a number of ways you can get out of this. Again, I'm not worried about that as long as you're not worried about it. Get through it any way you want to do it, but I suggest going about it this way. It's not a bad way to go. If you've got negative 12s equals negative 3, you always divide by the exact same number in front of the letter. I know here you're adding the opposite. I get all that. Here you're not dividing by the opposite. You're dividing by the exact same number. Oh, there's a negative 12 in front here? I'm going to divide by negative 12. Negative 12 divided by negative 12. Negative divided by negative is positive. It's positive 1. Positive 1 times s is just s. Negative divided by negative, we said, is a positive answer. You're done, or at least almost done. Isn't 1 times 3, 3? Isn't 4 times 3, 12? And that's 23. A lot of ways to go here, and we're gonna figure it out. We're gonna keep going here. So you got that's 23, 25. They're playing some interesting games with us, and let's play the game. Again, number of ways to get the right answer. Let's figure out what we think is the best way to get the right answer. Let's see here. Got this. You got 7x over 8. Sounds good to me. Okay. There's a number of ways to go here, guys. When I'm about to show, I can't show you every way. We sometimes run out of time. Let's try not to. The board here is not the best. It's got some stuff on here. The chalk slides a little bit, but it's okay. I think it's pretty legible for you guys. The chalk that I'm fortunate to use is good enough. It can overcome a lot of that stuff. Okay, we get to here, guys. I'll tell you what. I think usually if there's fractions all over the place, it's a good idea to get. It's an equation. It's a good idea to multiply by a big enough number that all the fractions disappear. You cancel out all the denominators. I tell you what. I'm going to do. You've got. Here's an 8, here's a 4, here's an 8. Tell you what do you say I multiply by 8 on each side and cancel everybody out? But be careful. If it's a multiplicative array, only one cancellation takes place. Is that clear? When there's an entire multiplicative array and there's no addition or subtraction, then when you multiply, you only hit one of the items. You only hit one of the factors. But when there's addition going on, you distribute the multiplication all the way across. It's a big difference. Let me say it again. If there's a multiplicative array and there's no addition or subtraction present, if you multiply or divide, you only hit the multiplication or division with one of the factors. You only link up with one of the factors. Even if there's a whole bunch of factors, you only hit one of them. If there's multiplication or division going on across an array that is only multiplication or division and there's no addition or subtraction going on. Pretty important stuff. When there is addition or subtraction going on, you will distribute the multiplication or division. All right. Guys, to put it in plain English, let's just do it. Here goes. I'm going to multiply by 8 on each side. But you got to put parentheses around everything on the left-hand side and everything on the right-hand side. You got to put parentheses around everything on the left, and you got to put parentheses around everything on the right. Well, okay. Just play it safe. 8's the same as 8 over 1. Go 1x like that. 8's the same as 8 over 1. Got this. 8's the same as 8 over 1. Here goes. That cancels. You got 1 times 1x is 1x. 1 times 1 is 1. 1x divided by 1 is just 1x. Leave it alone for now. The 4 goes into the 8 twice. 2 times 1 is 2. 1 times 1 is 1. 2 over 1 is 2. This guy and this guy cancel. 1 times 7x is 7x. 1 times 1 is 1. 7x divided by 1 is 7x. Okay, time out. We got down to here. And again, you got the feature. You can always go back and look at some of the arguments I'm making here if you don't catch it in the first iteration of walking through here. But we got this. We got it looking like this. And let's take it from there. Let's actually solve it. That's where that's pretty important. So what we have here All right, guys, maybe I'll stay close here and take it from there. We got 1x plus 2 equals 7x. Okay, shouldn't be too bad. Let's deal with it. Let's get all the x's on one side. Let me add a negative 1x on each side. 1x and negative 1x is nothing. We got 2 right here. 7x and negative 1x is 6x. Doesn't matter the order in which we set these equal. 2 equal, it's like saying Frank's age is equal to Joe's age, or Joe's age is equal to Frank's age. Well, if they got equal ages, it doesn't matter who I mentioned first. Frank's got the same age as Joe, Joe's got the same age as Frank. So it's called the reflexive property. We get to here, you divide by the exact same number. Well, it's a positive, you divide by positive. If that was a negative 6, you would divide by a negative 6. But since it's a positive 6, you divide like that. We're almost there. I mean, 1 times 2 is 2. 3 times 2 is 6. Sounds good to me. X equals 1/3 for problem number 24. So that's problem number 24, guys. All right, let's keep playing this game, I guess you could say, guys. So let's look at 25. 25 is saying 15 minus 6w. 15 minus 6w equals 25 minus 2w. I think you're better off converting everything into addition. I cannot emphasize how two real numbers in a subtraction, a minus b, where a and b are real numbers, a minus b is a plus the opposite of b. Converting to addition is a great idea. At the end of the day, do what you want, but I'm telling you, it's a great idea. So let's see what we can say. So we're looking at this right here, guys. I'm gonna leave this guy alone for a second. I'm just gonna leave him alone. I'm gonna write it down again. That right there is going to be written down in an equivalent manner. I like to add, I've already said it, now I'm going to try to deliver on that. Minus 6w is plus the opposite of 6w. Minus 2w is plus the opposite of 2w. I like to do that. Let's see how this game gets played. Let's get the w's all over to one side, and let's get the regular numbers all over to the other side. Which side is which? Doesn't matter. Get the w's either to the left or to the right, and then get the numbers to the opposite side and have the equation set up. So a number of ways we can go here. Tell you what I'm going to do. I'm going to add 2w. Negative 2w and positive 2w is nothing. Negative 6w and 2w is negative 4w. And the 15 is here. I chose to add 2w on each side. As long as you do the same thing on each side of the equation, it remains an equation. It remains something you can say are equal. If I have 1,000 pounds on one end of a teeter-totter and an equal distance from the fulcrum from where the 1,000 pounds is, I have another 1,000 pounds, it's perfectly balanced. If I take 700 pounds off of the 1,000 pounds on one side, I better take 1,000 pounds off the other side as well. If I double the weight on one side, I better double the weight on the other side, et cetera, et cetera. If you do the same thing on each side, the teeter-totter stays balanced. Okay? Let me add a negative 15 on each side. It really lends itself nicely. 15 and negative 15 is nothing. 25 and negative 15 is 10. Here we go. Here we go again. Divide by a negative 4. Why? Because there's a multiplication by negative 4. You always divide by the exact same number that's in front of the letter. W equals this divided by that. And what is it? Well, it's a lot of things, I guess you could say. Let's, this is what the W is going to be, that's for sure, after the end of the day on this thing. How about 2 times 5? How about 2 times negative 2? That's 5 over negative 2, which is the same as negative 5 over 2. Okay, that's another thing we need to talk about. If you ever got A over B, and there's a negative right in the middle, negative A over B, that's the same as negative A over B. It's the same as A over negative B. If there's one negative symbol, the negative symbol can be on the bottom, it can be on top, or it can be in the middle, as long as it's just one of them. So we can just bring this right up here. What is this equal to? Well, this is equal to negative 2.5. Negative 2.5. It's also equal to negative 2.5. It's equal to this. It's equal to that. This is probably the one where they're staying. They're not getting too funny with us. But all three of those mean the same thing. And that was problem number 25. Let's just confirm that when we're looking at it. Absolutely. Absolutely. We got it. Yeah, looking good. So let's keep playing the game, I guess, guys. Let's look at 26, 27, 28, 29, which are kind of, they're talking about how to solve certain things. Gives us an excuse to say a few things as well, you guys. All right, so again, it's just remember this. Remember the distributive principle. Remember all the rules. If you know the rules, you win. Simple as that. If you know the rules, you've got a good chance when things, even if you're kind of in the dark on how to proceed on something, proceed according to the rules that you've memorized, that you know, the rules with which you are comfortable. Proceed with those. Proceed with those. Okay, so got what we got, guys. Let's keep going. So for 26, again, I cannot emphasize enough, man, if you're in doubt, I would add. Just add. It gets you out of a lot of trouble. It makes it less confusing. It may look awkward at first, but it works. It works, and it works well. This is what this thing looks like. Let's copy it down, and let's convert everything. Let's convert all the subtraction into addition, and let's see if it makes sense. Interesting. What I could say is, I ain't doing anything with that until I evaluate this and evaluate that. Well, the 9's already there. I'm not doing anything with that until I evaluate this. The 9's already there, nothing to do. And I evaluate that. I'll tell you what. Are you okay with this thing right here is the same as this thing times 1? You do that, go plus the opposite. This is 9 plus, let's go, minus 5h is plus a negative 5h. Wow, let's see where this is going to go. It's a little messed up. If you got another, there is another way to do this. If you want to do it another way, take the subtraction, and this becomes minus 2, minus a minus, distribute the subtraction. Distribute the subtraction. This is minus 2, this is minus a minus, becomes plus 5h. That works too, and it might be easier actually. But this is a little more rigorous. Negative 1 times 2 is negative 2. Negative 1 times negative 5h is 5h. 3h is 3h. 9 and negative 2 is 7. Okay, I mean, the rest is what we know how to do. Let's just do it right. The big thing is where you're going to make the move. I mean, right here, you could have just taken the minus and, minus and distributed it throughout, and been 9 minus 2 minus a minus is 5h, and that may have been easier to look at. That may have actually gone easier, guys, had you done that. A lot of ways to go here. Know all the ways to do it. That's a good way too. When you get to here, why don't you subtract 5h on each side or add a negative 5h? Here we go again, right? We got 7 here. 3h and negative 5h is negative 2h, which is the same as negative 2h equals 7. Divide by negative 2. Always divide by the number that's in front of the letter. H equals negative 7 halves. H equals negative 7 halves, which is the same as we said, H equals negative 7 halves. It's the same as H is negative 3 halves. H is negative 3.5. So you got negative 3.5, negative 3.5, or negative 7 halves. Again, just to confirm, I think I already just looked at it, but let me just kind of forward. That should be negative 7 halves, absolutely. Let's keep going, I guess. So we got 27. So 27 is saying, here we go again. I mean, there's a number of ways we can go here. I personally like the tutors. They're going to show you different ways, possibly, which is not a bad thing, but you got to know what you're doing. Don't get confused, So you're looking at something like this. Well, if you're looking at something like this, keep looking at it. I mean, I'm going to write it down again. And I want to kind of see what's going on with it when I do it. I don't always need to do this because I always forget that I'm on film. You can always go back and see what it looked like originally. I made the move. But here it is. Minus 1 is plus a negative 1. And 4 times 3d is 12d. 4 times negative 1 is negative 4. It's a lot easier than you think it is. But you still have to be careful. Get like terms together. Remember, if you add apples and apples, that's another thing. If you add apples and apples, you don't get square apples. When you multiply apples and apples, you get square apples. Sure you do. If you allow me to say it that way. If you multiply x's and x's, I get square x's. There's a whole bunch of x's. I got x's going to a particular power. If I divide, I tend to get less powers. If I multiply, I tend to get more powers. There's a lot of ways you can argue that. The devil's in the detail. But generally, we can think of, okay, tend to be more powers when I multiply, tend to be less powers when I divide, and when I add or subtract, the powers never change. The letters and exponents never change when you're adding. The letters and exponents present never change when you're adding or subtracting. If I add A's and A's, I get more A's. If I subtract A's from A's, I still got A's. I don't have 10 apples, take away. If I have 10 apples and you take 2 apples from me, I don't have the number 8 anymore. I don't have $8. I got 8 apples. The letters and exponents never change when you're adding or subtracting. When you're adding or subtracting quantities, the quantities, the tail end of everything, the terms never change, the front end stuff changes. But if I had 10 apples and 8 apples, I got 18 apples. If I got 10 apples minus 8 apples, I got 2 apples, but still apples. If I multiply 10 apples by 8 apples, I got 10 times 8 and 8 times 8 is squared, as apple squared. Okay, so be aware of that. We have what we have here. Let's see what we have. 7 and negative 4 is 3. This is 0. Okay. You know where I'm going. I'm going to add a negative 3 on each side. I'm going to get the letters all by themselves. 3 and negative 3 is nothing. I got to do the exact same thing on each side. I get down to here. Give yourself a logical presentation of what's going on. Divide by a positive 12 on each side. That's negative 3 divided by 12. Wait a minute. Negative 1 times 3 is negative 3. 4 times 3 is 12. There you go, for 27. So you're looking at that. I mean, how that's going to play out. Okay, let's keep going. A lot of ways to go here, guys. I might as well, like I said, early on like this, it's, you know, it's good to look at some of this stuff pretty intensely, pretty rigorously, and that's what we're doing, I hope. That's 27. Yeah, the negative 1/4. 28 and 29. Let's see how we can play that out. All right, let's keep going. 28. 2 times the quantity x minus 4 equals 5x minus 2. 2 times the quantity x minus 4 equals 5x minus 2. Guys, I like to add. You know, I write them out more rigorously. You already have this on film, so you can always go back. But I convert everything to addition. You don't have to, but just get it right. Minus 4 is plus a negative 4. Minus 2 is plus a negative 2. It's called the distributive principle. We've been there. 2 times x is 2x. 2 times negative 4 is negative 8. 5x is 5x. Negative 2 is negative 2. You can play this a bunch of ways, guys. I'll tell you what I'm going to do. Let me get the x's over to the left and the numbers over to the right. But you don't have to do that. You say, well, I don't know, this is a positive number. I'd like to keep the numbers positive. I'll get this guy over here, and I'll get the other one over there. It doesn't matter. Just get it right. Tell you what I'm going to do. I'm going to add a negative 5x on each side. 2x and negative 5x is negative 3x. That's negative 8. This and this, I engineered it to be 0. It is 0. So you get down to here. You get negative 3x plus negative 8 equals negative 2. Tell you what I'm going to do. I'm going to add a positive 8 on each side. Negative 8 and positive 8 is nothing. Negative 2 and positive 8 is 6. Okay, starting to look pretty good. Divide by negative 3 on each side. You know where we're going. You always divide by the exact same number in front of the letter. If it's a negative, you divide by a negative. If it's positive, you divide by a positive. 6 divided by negative 3 And there you go. It's 28. There's a number of things, guys. I mean, and we'll get into more detail on this as things go on. Might as well throw it at you now. They got, if A is a real number and X is a variable, and let's say it's squared, and B is a real number, any real number, A is any real number, X is a variable, it's squared, B is what it is, X is this, C is another real number, so these are constants. A, B, C are constants. X is a variable. You set it equal to 0. They call it the quadratic equation from square. Notice there's a square term in there. There's going to be two solutions because the degree of the polynomial tells you how many solutions there are when you set it equal to 0. The great mathematician Gauss talked about that, one of the greatest mathematicians ever. There's a formula for the answer for X. What guarantees to answer is you take the opposite of B. Now, if B is a negative number, the opposite of a negative number is going to be a positive number. The plus or minus guarantees two scenarios, guarantees two answers. And you got this, you got B squared minus 4AC, the whole thing over 2A. That's the quadratic formula. You'll see it again at some point or another, and you're seeing it now. You're seeing it now. I don't need it for the problem I'm about to do, but I just wanted to kind of give you the exposure to it. This plus or minus scenario gives you two different answers. The two different answers are associated with the second degree polynomial. If this would have been to the 10th power, according to the great mathematician Gauss, if this were the 10th power, there'd be 10 solutions. Crazy stuff. The proof of it is not very difficult, they say, when you use complex numbers. We're not going there. That's not our business right now. All right. Let's look at 29, and it maybe goes pretty straightforward. 4x squared minus 25 equals 0. There's a way you can do it by factorization. There's this thing called, and I do go into this. I go into this in other places. What the heck? We got this far. I might as well tell you some stuff. How you can get some of the answer to this. You've seen it. I think you're going to see it in other scenarios as well, where I've done films earlier, prior to this. But I don't know. The repetition's the mother of learning, I guess. Sometimes it's good to have it. It's good to have the background. So let's see what we do have. So I mean, you could look. If you had a squared minus b squared, that factors as the quantity a minus b times the quantity a plus b. If you got a squared plus 2ab plus b squared, that factors as a plus b times a plus b, which is the same as the quantity a plus b squared. Yeah, you can't just bring the square inside and hit the a and hit the b and say you're done. You can only do that when there's multiplication and or division going on only, with no addition or subtraction. If it's multiplication and or division going on only with no addition or subtraction present, you can bring the exponent inside and hit everything and you're done. It's that easy. But when there's addition or subtraction, it doesn't work that way. You've got to do the distributive principle in a sense to make this right here gets written like this, and then you distribute the a all the way across, you distribute the b all the way across, and you get this. So you got to be really careful there. You got a squared minus 2ab plus b squared. That plays like this, a minus b, like that, which is the same as this. And again, same rules. You can't take shortcuts when there's addition or subtraction present. So we're looking at something like that. Okay, I didn't want to avoid that one. All right, let's see what we got here, guys. Forgive me how that looks, but So that's associated with that up there. Obviously, all this stuff. All right, so they're one and the same. We're talking about these two right here, and then this right here. All right, and then what we have down there. Let's see what I can say here. There's other things that happen. There's a cubed plus b cubed. How's that factor? That's kind of a crazy thing, the way that factors. It almost looks like one of those, but it's not. And you can't take it further. You can't take it further than what I just did. And if you got this, so there's a lot here, guys. You may have seen it before. If you didn't, you're seeing it now. You should see it again in some other films that I'm going to be sending out. But just wanted to make sure it's, in case something's missing, there it is. Again, this is also pretty big time important. So some of this stuff I'm going to leave a little bit. Okay, so looking pretty good, guys. Doing pretty good here. We've got this. There's a number of ways you could play this. This right here, 4x squared is the same as the quantity 2x squared. You could take the quantity 2x and square it. 25, you can take the quantity 5 and square it. And that looks a whole lot like a squared minus b squared. Well, wait a minute. Didn't we say that plays out? That plays out like a minus b, a plus b. So you can play it like that. I'm going to give you 2 looks at this thing. You could take 3 looks at it. You could even plug it into here, putting the middle term equal to 0, because there is no bx. There is no middle term bx, so you'd call the b 0. And you could notice how you write everything in terms of addition. There's a lot here, guys. There's a lot here. Let me say this, and we'll move on. Let me just at least say it. This right here becomes 2x minus 5, then 2x plus 5. If you grind it out, you'll see it's equal to 0. And that's where that's coming from. If this factor is 0, or if this factor is 0, the product is 0. The only way you can get 2 real numbers multiplied together being equal to 0 is if they're both 0 or one of them is equal to 0. Somebody's got, at least one person has to be equal to 0. One of them has to be equal to 0. Well, you could make this guy equal to 0. The way that would happen is if you had 5 over 2, the 2's would cancel. You got 5 minus 5. So x equals 5 over 2 would work. Or 5 over 2, negative 5 over 2, and that would be x equals negative 5 over 2. So these make it happen. You got x is equal to, and that's where they go plus or minus 5 halves. Okay, time out. How did I get that again? We said you could set this guy equal to 0. The 2x minus 5, you could set him equal to 0. Or you could set the 2x plus 5 equal to 0. Well, if you do the algebra, add 5 on each side, divide by 2 on each side. Here's one answer. Add a negative 5 on each side, divide by 2 on each side. Negative 5 halves, positive 5 halves. That's how it worked out. There's your answer. Pretty important, pretty interesting. Is there another way you could have done it that could have gotten you out of the woods if you weren't feeling too comfortable with this just yet? Hopefully you want to get comfortable with this stuff. Hopefully, you need to get comfortable with this stuff. You need to feel good about it, how it all works out. Okay, so we got this. Okay. Yeah, I'll give you another look at it. Plus or minus 5 halves is what's going to run the show on that. As it was, right? We had it set up that it was 2x minus 5. We had 2x plus 5, both quantities, set equal to 0. And we played the game and got the two answers. I got another way to do it. Why don't you add a positive 25 on each side? Minus 25 is plus a negative 25. All right, I'll just leave it minus. Either way, it doesn't matter. But minus 25 and positive 20, you know, this is plus a negative 25, plus 25 here. Add 25 on each side. Well, that's good. These guys are gone. Divide by 4 on each side. Now, square root that. Square root this. It's got to be plus or minus because a negative times a negative will give you the positive as well. So there's where you're getting the plus or minus on that. When you're getting the square roots here, you just right off the bat going plus or minus. Same answer. That's 29. Let's talk about 30, 31, 32, 33, 34, 35. Okay, these are word problems, pretty excellent. Let's do our best with them, and we'll take it from there. Okay, let's set it up. So what we have here, guys, for problem number 30 is, and you'll see it as it reads out, as it scrolls out at the end, you guys and stuff. But let's talk about it a little bit. Number 30 says. Number 30 says, velocity v, acceleration a, and distance s are related by the formula v squared equals 2as. Find the acceleration when the velocity is 8 meters per second and the distance is 16 meters per second. Okay. Guys, don't be too afraid. You know, I think when you see this, when you're holding on to the paper, or just looking at the problem, they're saying this is a formula. S is this is acceleration, this is distance, this is velocity. They are telling us if the velocity is 8 meters per second, so 8's the key number there to be, 8's the key quantity to be looking at. 8 meters per second, and the distance is 16 meters. Plug those in there and find out what's going on. Find the acceleration. Now there's a number of ways to play this. You could, symbolically speaking, do the following. 2as, right? And let me see here. You got two. If I want to solve for a, I'm going to divide by 2s on each side. The 2 goes, the s goes, A becomes V squared. So here's the A right here. Get the A by itself, divide by 2s on each side. And that's a symbolic way to write this. Let's get the actual answer. Well, they told us V was 8, so square it. They told us S was 16. This right here, there's a lot of ways to go here, guys. A lot of ways to go here as well. Take this, get 64. Take this, get 32. Let me see how they want to play the game. Now you got to watch out. You got to really watch out. This is 8 meters per second. So you gotta really watch out. This is fine what we did, but let's be careful how we did it. This is fine what we did. This is 8 meters per second squared over 2 times the quantity, 16 meters. This is 64 meters squared per second squared. This is 32 meters. 32 goes into 64 twice. Meters goes into meters squared. Got to watch the units. If you want to play it straight, we got to really watch the units we're doing here. I just want to see how they wanted to say it. Accelerations, meters per second per second. You got it. You got it. That was 30. 31. The perimeter P, length L, and width W of a rectangle are related by the formula P equals 2L plus 2W. If the perimeter of a rectangle is 120 centimeters, its width 24, find its length. A lot of ways to go here, guys. They're basically telling us the perimeter, the measurement around, is double the length plus double the width. I guess that makes sense. I mean, if this is width, and this is width, and this is length, and this is length, length and length plus W, well, length and length is 2L, W and W is 2W. So we got that. If the perimeter of a rectangle is 120 centimeters and its width is 24, find its length. Okay, let's play the game. We can play this a bunch of ways. Let's take this. Let's set it up with P equals 2L plus 2W. If the perimeter of the rectangle is 120 centimeters, so P is 120. The length we do not know. The width, and its width is 24. Two times 24 is 48. Subtract 48 on each side, right? Add a negative 48 on each side. Should be pretty interesting. This is going to be 72 when you do it. I don't know what L is. I don't know what 2L is. I do know 48, negative 48 is nothing. I got this. When you get down to here, guys, we're talking about, it doesn't matter what order you put it in. 72 equals 2L, 2L equals 72. Divide by 2 on each side. You know where I'm going. Since everything was centimeters from the get-go, there it is. Okay, that's 31. Okay, good deal. Let's talk about problem number 32. Problem number 32, a 96-inch board is to be cut in 3 parts so that the second part equals the first, and the third part is 24 inches longer than the first. Find the length of the 3 parts. Okay, that's kind of neat. You've heard me say this already in this film quite a number of times. You're probably going to hear me say it a lot throughout the course, I guess you could say. Let's talk. So they're saying a 96-inch board is to be cut in 3 parts. A 96-inch board is to be cut into 3 parts so that the second part equals the third. So that the second part equals the first, and the third part is 24 inches longer than the first. So find the lengths of the 3 parts. Okay, so there's the first, there's the second, and there's the third. Wow, there are a number of ways we can go here, guys, but I'll tell you what I'm going to do. Let's figure this out. The 96-inch board is to be cut into 3 parts so that the second part equals the first. The second part is going to be x. The first part is going to be x. And the third part is going to be 24 inches longer than the first. We got x, we got x, we got x plus 24. First, second, third. Here we go. Well, they're going to equal that. Let's cross that bridge when we need to cross it. Here's the first. Here's the second. Here's the third. And it's the 96-inch board. It's the 96-inch board that's being cut. So find the length of 3. Oh, there you go. That's the hardest part, guys. It is x plus x plus x plus 24 equals 96. Let's find x and we're set. X plus x plus x is 3x. 24 is 24. You've got to make that connection. Repeated addition is multiplication. X plus x plus x. X plus x plus x is 3 times x. There we go. Let me subtract 24 on each side, or add a negative 24, however you want to do it. That's out of there. You got 3x here. Subtract here, you got 72. 3x equals 72. Divide by 3 on each side. X is 24. First is 24, second is 24. The other one is 24 plus 24 is 48. There it is. See how they reported it, guys. I mean, it's the right answer. We're not worried about that. But there they are. 24, 24, and 48. You got it. 33, 34, 35. Let's talk. Excuse me, guys. I want to check that everything's okay. Doing good. Okay, pretty good. Show you how the taping's going, I guess. Number 33, a train traveled from city A to city B in 4.5 hours at a speed of 72 miles per hour. The return trip was made in 4 hours, not 4.5. 4.5 was to get there, and the return trip was made in 4 hours. Find the speed for the return trip. Okay, there's a lot of ways you can go. Let's opt for an easy way to look at it. Distance is distance. And there's a lot of ways to play that, I guess you could say. Got to where it was going to go at 72 miles per hour. 72 miles per hour, traveling for 4.5 hours. Traveling for 4.5 hours at 72 miles per hour is a distance that it traveled. It is the same distance it travels going back. It's going r, but it's only hours. In the end, they're both going a distance d. Well, let's have a look. I mean, it's 72, 4.5, 4 hours times r, divide by 4 on each side. It's 72 times 4.5. Notice I'm not even multiplying this stuff out. I'm going to divide by 4. I might have an easy way out of this thing. If I divide by 4, the 4 goes. Four and a half times 18. That should be interesting. 4.5 times 18 should come out to 72 plus 9, 81 miles per hour. That's it. End of the story. You could have done this. You said, look, hey, this thing's going at 72 miles an hour to get there. It's going for 4.5 hours to do the trip. How far of a distance did it travel? Well, 4 times 72 is 288. 0.5 times 72 is 36. So 36, forgive me, yeah. 0.5 times 72 is 36. 4 times 72 is 288. 288 and 36 is 324. If it went 324 miles, it went at a speed r, and it went for 4 hours. Why don't you divide by 4 on each side? When you divide by 4 on each side, you end up getting 81. And that would have, maybe that's a little more straightforward, a little more intuitive. But I wanted to give you both looks at that to actually get that across. All right, guys, that's 33. Let's do 34 and 35. All right. 34, 35. Okay, let's take a look. So with this right here, guys, we got 34. A bus and a truck leave the same terminal at noon, traveling in opposite directions. The bus travels 55 miles per hour, and the truck travels at 45 miles per hour. So the bus is going 55 miles per hour and the truck is going 45 miles per hour. They're both going in opposite direction. In how many hours will they be 150 miles apart? Well, I mean, it's easier to get far apart when you're going in opposite directions. It's really hard to get far apart if you're both going in the same direction. You really got to be outrunning the other vehicle to get ahead of them by a lot. So basically the argument here, guys, pretty straightforward. If they're going to go in different directions, so they're both taking off. There's a bus, there's a truck. The bus goes faster than the truck, but at the end of the day, (150 miles apart). Well, I'll tell you what I'm going to do. If they're both traveling, in how many hours will they be there? Well, I'll tell you what, there's the speed of the bus. Since distance is multiplied quite a bit if you're going in different directions. People get far apart when they're running away from each other. If they're running in the same direction, one's got to be going a lot faster. Basically what we mean is you put the rate of speed of the truck plus the rate of speed of the bus, you add them together, you multiply by time, and that'll tell you, and d is distance apart. I'll tell you what I'm going to do. I want to be 50 miles apart. The speed of the truck is 45. And, right, the speed of the truck is 45. The speed of the bus is 55. T is. Well, I'm going to add these together. Let's write that a little different way. Not much different way, but a little different. Divide by 100 on each side. $150 divided by 100 is 1.5. 1.5, 3 halves. .5 hours. Let me just make sure I'm speaking their language. Yeah, I said 1.5 hours. That's fine. Okay? And that was 34. 35. One car leaves a motel traveling at 42 miles per hour. A second car per hour on the same highway. How long does it take the second car to catch up to the first? That's a different story. One takes off early. One takes off an hour early, gets a head start, but it's not going as fast as the second car, which takes off an hour after that. So one of the cars takes off an hour early, but it's not going that fast. After the first car that's not going that fast took off, after an hour, a second car is going to take off and go faster after an hour. So the other one's got a head start, but he's going to catch him. Now that's a different story. It's a little different story. It's not this. It's going to be this. The rate of speed of the fast car minus, let me not write it like that. They both, when they catch up to each other, when the fast car, which left an hour later, catches up to the slow car, which left early by an hour, right? The slow car is going to get caught up. They're both going the same distance. How long does it take the car to catch up? Not only that, I'll tell you at what mileage point they caught up. Though they don't even ask us. Here's what happens. The slow car, we'll call, it'll travel a distance d. Its speed is 42, and it'll travel for, now you can write this a couple different ways. It's kind of tough. It'll travel t, the slow car. It'll travel for a time t at 42 miles per hour. It'll cover a distance d. The other car, the fast one, will be going 56 miles per hour, but it'll only be traveling for an hour less. But it'll cover the same distance. Cover the same distance. These are if d equals d, this and this equal each other. 6 t minus 1 equals 42t. Interesting problem. Distribute the 56 plus a negative 1, it's up to you. 56t minus 56 56t minus 56 equals 42t. Minus 42t is plus the opposite of 42t. Let me add a negative 42. Let me add a negative 42t on each side. Whoa, that doesn't cancel. Sorry about that, guys. 56t minus 42t. Minus 42t, okay. It's not going to cancel completely. Do the addition here, you got 14t right here. equals 0. Let's add a positive 56 on each side. Out of 4 hours. 4 hours from when the 4 hours of the slow car traveling, and t minus 1 is 3 hours with the fast car traveling. That depends how they're asking the question here, guys. The way they're asking it is, yeah, they give 3 hours for an answer, man, but I mean, that's, be careful, yeah. Let me see how they ask the question again. How long does it take the second car to catch up to the first car? No, that's okay. That's okay. Yeah. 4 hours after the slow car leaves, it gets caught. 3 hours after the fast car leaves. 3 hours after the fast car leaves, the fast car catches the slow car. So three would be the answer. How long does it take, the way it said it, right? It said, how long does it take the second car to catch up? How long does it take the second car to catch up to the first car? 3 hours. Put a 4 right here. 4 times 42 is 168. 4 minus 1 is 3. 3 times 56 is 168. In 168 miles, at the 168 marker, just south of Chicago, if they started in Milwaukee going south, let's say, just south, somewhere south of Chicago, they end up meeting up, at 168 miles. Notice you put the 4 here, minus 1, you got 3. 3 hours after the fast one took off. 3 times 56 is 168. 4 times 42 is 168. They didn't ask us at what mileage marker that happened, but it's there. Okay. All right, guys, sometimes I'm going to go faster, but we at least got to get the background here. We'll be talking about this stuff in class whenever we need to do so. I do thank everyone for their time, and all the best. We will talk soon.